I ran out of time in the last video that I was doing. We were finishing reducing this second example of rational expressions. Now I had gone so far as to do the top. I took a negative 1 on the top, and I showed that when you have a positive power, an even power, 2, 4, 6, 8, 10, any even power, we end up taking a negative 1 out, and that negative 1 then becomes just a positive 1. So you can just switch your first and second term around without having to worry about it. When you're doing an even power, when you're doing an odd power, 1, 3, 5, 7, 9, that's a little bit different. Let me do that part of the example. So, once again, I'm just going to leave the 3 way out on the outside. And I'm doing my Q and my P, but I'm going to take a negative 1 out. Remember, it's all still cubed. So I have negative Q and a positive P. So I can take this cube, apply it to both parts, and I'm now left with negative 1 cubed, and I'm going to switch the P and Q in order around, keeping the signs the same. P minus Q cubed. Now negative 1 cubed is negative 1 times negative 1 times negative 1. That's 3 negatives. 2 negatives give you a positive. The third negative takes it back to a negative. So we are stuck with this negative 1 out front, and it stays. So that's where it's different if you're doing an odd power. You can switch the inside parts if you have a negative there, but you have to keep a negative 1 out there. So if you have a choice, because either of these can be used, you don't need to do both of them. If you have a choice which one you are going to do, I always suggest you pick the easy one, and in this case, the easy one is the even-powered number. So, oops, sorry about that. I'm going to leave the bottom the way it is, and I'm going to take a negative 1 out of the top. So now this equation, taking that off to the side, becomes Q minus P to the power of 4. I used this part right here, and I ignored that one. And the bottom stays the same. Over Q minus P cubed. Now, since I have the same base left, I can take the exponents and subtract them. I'm left with 1 at the top. So my end answer ends up being Q minus P to the power of 1, or just Q minus P. Now, I still haven't done any restrictions. But that's a new video.